All right, good afternoon, everybody. Welcome to Organic Chemistry Chem 170 with your host, me, Dr. White. Good news, YouTube channel 170, Chem 170 is up and running. If you happen to have a chance, go to YouTube. In the YouTube search box, put in CHM space 170 space ECC, and you'll see the video that I put up for Monday's lecture. Boy, it was a monster upload. It was almost a 3-hour video. But I have two machines, so I let this one upload it, and I was working on my other one, even though I probably could have done that. So anyways, that's up and running. One of the things I would like, I don't know if I talked about it on Monday. Did I talk about the signature sheet? Did I? Maybe not. Real quick, let's go through it. All right. You should see on the screen now what I call the signature sheet. This is something I've been doing a long time at ECC. I do it at my other school. I found out about this first year I was teaching from another faculty. That's a good thing. And here I have both a PDF and a Word document. What I'd like you to do is print your name in here or write it however you want to do it if you don't have a printer, and then sign it and date it. And what it essentially says is you've read the syllabus and you understand the policies for this class, and you understand it's your responsibility to abide by these policies, and that if you fail to abide by these policies, it will result in the consequences outlined in the syllabus. And this is a standard contract I do every semester, every class I teach, wherever I teach now. And what I probably forgot to mention, but it's in the syllabus, if I don't have this by the first test, you can't take it. Ooh. But I'd appreciate if you get it to me as soon as possible, because since I'm not taking attendance, in about a week, I'll be asked to fill in who's coming to class and not. And this was what I'll use, because that's a state mandate. So the school gets federal aid and state aid based on how many people have showed up. And we also have to do that during midterm, and all schools do that. All right. Let me remind you, in my class, there's no such thing as a dumb question. And I'm still learning Zoom meetings, even though I had a lot of practice this summer. I think the best way to ask a question in my class, and questions are encouraged, is unmute your mic. You should see in the upper corner, if you put your cursor there, there's a little blue square that says mute and unmute, and ask your question. Now you can use chat, but if I'm in share mode, it's hard for me to see chat when you ask a question there. But try either way, whichever you're comfortable with. All right, one of the most important things, besides there's no such thing as a dumb question, that I was teaching you on Monday is how many bonds to carbon? There are 4 bonds to carbon. How many bonds to carbon? 4. Hold on, let me fix that finger. 4 bonds to carbon. See, I'm ambidextrous. I can go like this. Oop, still doesn't want to stay fixed when it goes like that over there. But anyways, seriously, 4 bonds to carbon will always be your friend. On every test in the final, for answers that students had to write down, if they had remembered 4 bonds to carbon, 75% or more of what they wrote down, they'd realize, that's not right. So 4 bonds to carbon. And I'll be reminding you this a lot the next couple of lectures, because it really is your friend. Now, what were we doing? We were talking about how to name alkanes, which are acyclic saturated hydrocarbons. Remember, a hydrocarbon is a molecule with only carbon-hydrogen atoms. Saturated means it only has carbon-carbon single bonds. Acyclic means it's straight, not in a ring. One of the things I realized Monday was normally in class I have these models. Guess what? They're sitting in my office and I'm not going there for a while. In fact, I'm not allowed to. Well, I could, emergency, but I'm not going to risk it. But there are other ways we can do. All right, now. One of the things that I mentioned, and now it's a public service announcement from me, Dr. White. And that is, here are the IUPAC names for the alkanes. Remember, IUPAC just means the official name, even though it's cool to say International Union of Pure Applied Chemistry. But I'm a chemist, so I think that's cool. But you should know methane, 1 carbon, ethane, 2 carbons, propane. Oh, you remember propane? That's used in your barbecue, 3 carbons. Butane. How many of you have seen the little plastic lighters with the liquid in it you can see? They're called butane lighters because that liquid you can see is actually butane. It's under pressure and it's a liquid at room temperature, not under pressure like that. It's a gas. Butane, 4 carbons, pentane, 5 carbons, hexane, 6, heptane, 7, octane, 8. Hold on a second. Octane. I've heard that name before. Why am I thinking a gas station? Oh, if you go to a gas station and you go buy gas, what do they have? The octane number. And back about the time automobiles were starting to be popular, about the 1905, 1910, the best gasoline had the highest amount of isomers of octane, not just straight, but other isomers. And that's how the octane number developed, and they still use it. Oh, I have all afternoon. Really public service announcement. At one company that I worked for a number of years, because my position as a research development manager, some of the products I was responsible for, we sold to petroleum companies, otherwise known, as gasoline companies. And those are additives that are used in gasoline. And because of that, I got to go and visit the research centers of major gasoline companies in the United States and meet these people. And they taught me a lot about gasoline. All right, first thing, best gasoline, it's been this way for decades, is Shell. This won't be on a test, but this is a cool thing about taking organic chemistry with me, because you learn some things that are useful in your daily life. Shell is the best. Mobil is like there. Some of the off-brand names are pretty good. The very worst is BP, which used to be Standard. Do not buy that. It's garbage. Why do I say that? Well, it's true. People in the industry feel that way. But if you don't believe me, go back about 2 or 3 years ago, look on Google and the newspapers in Chicagoland, put in BP problem or gas, bad gas. And if you would find that about 2 or 3 years ago, maybe 4, the refineries in northern Indiana and that part of, I guess, south of Chicago in Illinois, the foundries there and the gas stations that got gas from the foundries, that gasoline was so poorly made that it destroyed the car engines of about 3,000 cars that BP had to pay to be replaced. Now, you want to put that kind of garbage in your car? Nope, I don't. All right, so Shell is the best, Mobil is really good. Now, If you go to a gas station, you'll see 3 different grades of gas and 3 different prices, regular, medium, and whatever they call their top level, nitrogen grade, and I'll teach you more about what that means later in the semester. Well, what it is gasoline has additive packages put in there. And that's what the chemicals of the company I work for sold to these companies. Most of the gas comes from oil, gasoline, but some things, chemicals are added to make it to perform better and help your engine do better. And the highest premium has the best additives. The regular has the smallest amount, but unless you have a Ferrari or Lamborghini, you can get by with the regular. Now, one of the things I was taught, and I have done religiously with a couple of cars, and it helps keep my engine nice and clean and healthy, is about 3 or 4 times, every couple of months, I'll let my gas tank go down to a quarter. Because of me, and it's just a habit of mine, I try never to let the gas tank go below half. But that's my own thing. I know other chemists at UCC go down to almost empty. I don't play that game. But anyways, let it go down to about a quarter and fill it with the highest premium gas. I do Shell or Mobil. And what that does is the extra additives help clean out parts of your engine, like your injector nozzles, your carburetor tips, and things like that. But you don't have to do it every time unless you have a Lamborghini or Ferrari, which mine hasn't come yet. Hopefully in a year or two I'll get one. Gosh, I'd like a Ferrari SUV. Even a Lamborghini. I knew someone who had a Lamborghini Countach. What a car. All right, so that's the first tip. Next thing, and let's see if I can find it quickly, because I don't know if I have a bookmark. And the answer is yes, I do. Does everybody see Gas Buddy on your screen? Everybody's okay, thank you. And if you want looking for this, it's not called Gas Buddy, it's called ChicagoGasPrices.com. And I've been using this for years now, and it shows you in a various zip code or other zip codes. And if I were to do Elgin, you can see the various gas prices. And here, the one I normally go to if I was at ECC is this, and right nearby across the street, there's across the literally small road, McLean or Fleetwood, there's also Marathon, which I've used, but this Shell is usually quite low. Now, if I live out in Schaumburg, and you can see the prices are some places lower. Here they're lower, and it's amazing. ECC is in Kane County, no 10-cent tax on gas. I live in Cook County, 10-cent tax. Sometimes Kane County is a lot cheaper, sometimes Cook County. There's no rhyme or reason, but I've seen price differentials as much as 40 cents a gallon. And if you're buying 10 gallons, that's $4, which is a nice savings. So this is my other public service gift to you. Look up ChicagoGasPrices.com. And every time I go to fill my tank, right now I'm not traveling like I used to because I'm working out of my home at both schools instead of going about 250 miles a week. Once a week, I take my car out and drive it around for 10 minutes, keep the battery and everything up to speed. So I'm putting almost no miles on. I can't remember the last time I bought gas, but when I was buying gas a lot, this is a good thing. All right, that's my public service. One more, how many bonds to carbon? 4 bonds to carbon. How many bonds? 4. In about a week, I hope you're not having nightmares where I'm saying, how many bonds to carbon? How many bonds to carbon? But I will be brainwashing you. All right, let's get back to where we left off. First of all, here are the IUPAC names for the alkanes. Now notice I only go up to 10. Actually, these IUPAC names for alkanes go up to thousands. 11 is undecane, 12 is dodecane, and so on. And in everyday life, you only use about 10 carbons. If you go a little higher, for a lot of the molecules we use in our everyday life, I'll teach you later in the semester, they're what we call common names. But it's important for you to know this and memorize it. Remember how I said write something down and say it 5 times? That will help you. Also remember, this is in Blackboard. Oh, that reminds me, something I didn't do. Quick thing, I teach at College of DuPage COD plus here, ECC. And at COD, except for due to the virus, in normal times, every 90 days we have to change our password. When I do that, I change all my passwords so I know they're up to date. So all this time in ECC, I think, is every 6 months for faculty. So I've never had a problem where I had to change my password because it was due. Well, at COD, they send out 15 days, 10 and 5 days, and the day before, emails, you got to change your password. I found out, or I should say COD does that. ECC doesn't. You go to login, and says you got to change your password. So that's why I got tripped up on Monday. Also, I think the computer gods were angry at me. All right, let's do something that I didn't do on Monday. And I can do that now. All right, you should see D2L, Chem 170, 100, et cetera, et cetera. By the way, the picture here, this is called the condenser. I had a real nice one in grad school. It brings back good memories. And there's another condenser you'll see on YouTube that I love. But anyways, I'll teach you about that later in the semester. You'll see content discussion, assignments. I won't have any quizzes, grades. I'll be uploading a class which you may not have, I do. If we go to content, you'll see over here, learning modules, which I was required to put in. Normally I don't, but that's for a net class they want. Lecture syllabus, later on there'll be extra credit. My YouTube videos, and I've got to put the new, I don't know if I have a link for that. Also, because over the years I've learned about the generation gap, and you people don't know good music or good movies, there's some lists of good things. How many of you know who Jimi Hendrix is? I see a couple of people. I can tell you this, I saw him live my senior year of high school when he was in Chicago. One of the greatest concerts I've ever been in my life. I had great seats too. Anyways, that's there. Now, in lectures, you'll see I have all my chapter slides. Like I have the alkanes, both as a Word and a PDF. And notice this, I have in there the alkanes, UPAC names, number of carbons, both as a Word and PDF, and key alkyl groups, both as a Word and PDF. And you'll see I have other chapters, and later on I'll talk about other things. One thing that, unlike Blackboard, D2L does something stupid because it's an old software. Notice if I scroll down, it has this thing, load more. You look, what's after chapter 11? Nothing. No, you hit this and it loads more, which is stupid, but it's an old software system. And you'll see at the end, and I'll talk about this before each test, I have actually a review for you. Stuff I'll go over is already written down. All right, once more, because overkill is good, you should know this chart. Hint, big hint, hold on. You should know the chart. Did you get it? Dr. White can be solely in front of a web. Now, the other chart you should know and start memorizing is the key alkyl groups. And these are carbons and hydrogens that are attached to the longest chain or a ring. There's a file with this I just showed you in the lecture, but I'm going to slow down now because I see some of you are copying it. Normally in a classroom, I'd write this on the board besides showing you the screen. And when you have one carbon attached to something, it's a methyl, two is ethyl, three, there are two possibilities. One is to the N carbon to a chain or ring, it's N-propyl. When it's the center carbon of three carbons that are this alkyl group, or otherwise known as substituent, it's isopropyl. When it's four carbons, when it's to the N of a four carbon alkyl group, it's called N-butyl. And three carbons connect to the center carbon attached to a ring or a long chain. It's called tert-butyl, but Dr. White is going to be a lazy organic chemist, which we are, and we usually call it T-butyl. On a test, you can do either one. Now, remember on Monday, I'd say you learn a lot about me this semester. Well, it's that time. Dr. White loves isopropyl groups and really loves T-butyl groups. They've been good to me. I've been good to them. Mother Nature likes them too, but Dr. White really loves isopropyl and T-butyl group. I've used them a lot in my research and they've helped. The other ones are very good too. And you'll find out soon to be your old friend, the methyl group. All right, so these are the alkyl groups. One of the problems I'll have is in Zoom, I can't have more than one file up on your screen at a time. Or if you can, I don't know how to do it, and I don't think you can. So this is going to be a problem. We'll have to jump back and forth. Now, on Monday, we started learning how to name alkanes using the IUPAC nomenclature rules. Nomenclature, which I'll never ask you on a test, is just a fancy name for names. That's the naming rules. And you already learned that alkanes without branches are named according to the table I just showed you, and in your book would be table, 2.1. Alkanes with branches, you have to find the longest continuous chain of carbons. And we're just doing that at the end of Monday, and we'll do that in a little while, continue on. And what you learn, groups attached to the main chain are called substituents, and saturated substituents that contain only carbon and hydrogen are alkyl groups. In this class, the two main types of substituents will be, and I'll teach you later when we get into aromatic compounds, halogens. The other one are, like you're learning now, alkyl groups. Now, one way is this way, how to change the alkane name for one or two carbons by dropping the ANE and replacing it YL. But I think it's easier. Memorize the table I gave you. And the main chain is numbered in such a way that the first substituent along the chain receives the lowest number. All right, I will never ask you on a test to write down these rules, but I will ask you to know how to use them. So let's go do some stuff. And since we went through this, I'm going to be real mean today and say, why don't you try this one first, and then I'll do it. How many carbons? I'm not going to even put in the hydrogens to confuse you. If I were in a classroom, I'd say, when you're done, look up and smile. But since not all of you have your video on, I'll ask, when you're done, give me a thumbs up like that or with your emoji. Thank you. I just have to do it once because I can see everybody. Thank you. And for those of you who don't have your video on or don't have video, use the emotion. I think that's what it's called. Button at the bottom of Zoom. All right. Let's take a look at this. I think everybody's done. I'll give everybody another 4.5 seconds. 1, 2, 3, 4.2, 4.6, oh, 4.5, done. All right, now if we count across, this is carbon 1, 2, 3, 4, 5, 6. I could start here, 1, 2, 3, 4, 5, 6. I could also go here, and I'll use a circle, 1, 2, 3. I'll put dots in here, 1, 2, 3, 4, 5. And I could also go 1, 2, 3, 4, 5. So there are two ways you can look at this. And the longest chain, if I count it correctly, and if I don't, correct me, would be 6. And that's all I'm asking at this time. Now, if we were to have...
I actually have a question.
Go back, I'll go back, yes.
Now, if we were to write them...
Did I count that right? 1, 2, 3, 4, 5. Go ahead.
If we were to write like the chains on our own and there were multiple branches, would we always write the branches coming off one side, so like always going down or always going up?
I don't think there's an IUPAC convention. Well, the answer is no. But most of the time, yes. I'll give you an example where the answer is no. Let me pin this.
And then I actually had another part to that question.
All right.
So when we're counting the different, like if we're trying to find the longest chain,
yep,
you can do like the horseshoe shape to kind of follow it. But if there was maybe a branch at the bottom and a branch at the top, would you then follow maybe like an S shape with it, or would it always be
you'd be following? Let's talk about longest chain. And I'm going to unshare for a second. Everybody see the chain I have around my neck right now? What is it? It's made up of links. And what we mean by chain in organic chemistry are carbons linked together. And we show that by a line. I have mentioned it, I should really bad, Dr. White. Each line is a pair of electrons, a single bond. And therefore, if I go back to this, I think, Samantha, or do you like being called Sam? Which way do you like?
Whatever comes out.
Well, which way do you like?
Samantha, because that'll just be easier to remember.
All right. That's fine, because there's a shortened version of my name with a Y. I don't even say it. And I've hated it since I was about 4. But Dr. White works best. Now, if we had more carbons here, that's your question, how would you count them?
No, if we had maybe like more carbons on a branch off of like the horizontal chain, let's say off of like the fourth one from the left, there's like another couple carbons going up. Would we
He
follow?
might over here be going this way or here.
I don't see your screen moving.
Oh no. Hold on. That's the part of Zoom I hate. Can you see the screen right now with the
Yeah.
in black? Which carbon are you looking at? Or is it the one?
Let's say like number 5, if there was another several carbons coming off of that, could you potentially start with the
There's
lowest
you,
carbon and then go up
when
the
you
chain?
look at the longest chain, you just have to start counting. I'd go 1, 2, 3, 4, 5, 6, 7, 8. If you count these new ones, 9, and there are a whole bunch of chains.
Okay.
And you just have to say what's connected. Now, in
Okay,
real life,
so,
you usually don't see anything this complex.
okay, I was just wondering how you would, okay, that makes sense.
Oh, hold on, time out. All right, time for Dr. White to get serious. There's no such thing as a dumb question. A lot of you have probably been abused by faculty who don't like questions. There's no such thing. You never have to go like this or feel in any way guilty ever for asking a question in my class, okay? So ask away. That's why you're here, to learn. And that's how I learned. And that's how I learned that lesson from Dr. Palavin, which I talked about. All right, let's do another one. Now, to answer your question, sometimes when you have more than one substituent on a carbon, you don't put them both underneath. Right here, can you see the screen right here? And that would be an example. All right, have fun. What's the longest chain? By the way, practice is good for your grade. And if you get a good grade, I get what I want. You'll have learned organic chemistry. See how sneaky I am? Oh no, all the hydrogens disappeared. No, I didn't put any in. This is one of the rare times when you won't see something except for a ring without hydrogens. All right, anybody need more time? Going once, twice. All right, let's figure it out, because I don't know, because I just wrote down a molecule. I'm going to go across 1, 2, 3, 4, 5, 6, 7, 8. I'm going to start from here. 1, 2, 3, 4. That's not too good. 1, 2, 3, 4, 5. That's not too good. 1, and I could have started here too, it doesn't matter. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I could go from here, 1, 2, 3, 4. Nah, 1, 2, 3, 4, 5, 6, 7. That's not larger than 9, so I'm going to ignore that. If I start here, 1, 2, 3, 4, 5, 6. Nah, 1, 2, 3, 4, 5, 6. So it looks like for this one, the longest chain is 9. And that's the skill you should have. Now, if you look at the first problem set, you'll see the first question I asked you, there are a couple of parts, find the longest chain. And remember what I talked about on Monday, riding a bicycle. Remember, you need to practice. And watching me do it is easy. When you have to do it, it's a little challenging at first. All right, let's move on. I don't know if I mentioned this, in this class, I've never given a multiple choice question on any of my tests. They're all short, fill in the structure or whatever. In organic chemistry, there are 2 skills you should have when it comes to nomenclature, naming. One is, here's the structure, give the IUPAC name. The other, which we'll go through today, here's the name, draw the structure, which means on my test, there are 2 types of problems I can give. This is one of them. Here's the IUPAC, here's the structure, give the IUPAC name. Now, the first thing you have to do is find the longest chain. This is simple. 3. Are there any branches? No. You look at the table, 3 carbons. Hopefully you've learned that's propane. And why don't you try this one? Hopefully you have access to the tables. In the future for this class, you might want to either write them out for now or print them out if you have a printer, because normally I would put this on the screen in a classroom. Hold on, I'm going to try something. Hopefully this won't get too absurd. First of all, hopefully you looked at what's the longest chain, and look quick and find it here. Everybody find it? Have you noticed there were 5 carbons, and that's pentane? Let's take a look. 1, 2, 3, 4, 5. 5 carbons, it's not branch, pentane. All right, first thing I'm going to ask you to do is figure out how many carbons in the longest chain. Time's up. Hopefully you all got 7. Now, in case you haven't learned the chart yet, hint, you should, but I'm going to jump over there. Why don't you find the chart name for 7 carbons? I'll give you 7 seconds. Time's up. It's heptane. So if I'm writing the name of this, the longest chain, 1, and you don't have to write these numbers down. I am, so you can see what I'm talking about. 7 carbons, heptane. And as soon as you say heptane, all these are spoken for. Am I done? And the answer is no, because look what's left over. And this is an alkyl group, CH3. What do we call that? Methyl. I should have switched to black, but it's too late now. Am I done? No. Which carbon is it on? And you number from both sides such that the carbon that the alkyl group is on, the first one, they always get the lowest number. If I start numbering from here, notice if you start from this end, it's 3. If you start from this end, it's 5. And our UPAC rules are you always number the alkyl groups to give them the lowest number. And I hope you all know, remember the math skills in my class are brutal. 3 is less than 5. So this would be 3-methyl heptane. Now, important public service announcement from me, Dr. White. And that is how many bonds to carbon? 4. And it's now your solemn responsibility in my class that whenever I write a structure on the whiteboard on your screen, if I make a mistake, instead of having 2 hydrogens, I only have 1, you tell me. And I should warn you, when I'm writing structures, I put in hydrogens at warp drive. For those of you who know science fiction, that means I'm going or trying to go at the speed of light as fast as I can. And I will make mistakes. So if I put down 3 hydrogens where there only should be 2, Dr. White, you made a mistake. That's your responsibility being in my class now. And I'm going to share, your turn, what's the IUPAC name for the following molecule? I'll give you a minute to 20 seconds to find out what's the longest chain. And by the way, those of you who have friends, parents, or other walking by your camera, you can have them join too. They're always permitted to watch. I won't charge you extra. See what a nice guy I am. All right, everybody know what the longest chain is? In case you forgot the names, let's go over to here. I'll give you a second to look on there. There's more than a second. I'll let you finish up because you can look up here to see what a CH3 group is called. Gave it away. All right, anybody need more time? Going once, going twice. All right, let's take a look at this. How many carbons in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8. If I started here, 1, 2, it'd still be 8. I could also do 1, 2, 3, which is the longest chain. I hope you all agree 3 is smaller than 8, so 8 is the longest chain. What's the root name for 8? Octane. As soon as I say that, this is all spoken for. Again, you do not on a test have to put the numbers or circle it. I'm just teaching you how to identify. Now, we have something left over. It's an alkyl group, 1 carbon. 1 carbon is methyl. Ooh, that just fit. And now, are we done? No, you have to say what carbon is the methyl group on. And if we start from this end, it's on carbon 2. If we start on this end, 1, 2, 3, 4, 5, 6, 7. Now, I think I mentioned, I'll mention again, this is how I draw my 7s. I learned that from my German teacher in high school taking German. And I thought that was the coolest thing in the world. And I've been doing it ever since. How many decades? I shouldn't have said that. But anyways, which is smaller, 2 or 7? IUPAC, the number for identifying, is always the smallest numbers, and therefore 2. So this would be 2-methyl octane. Now, if you're typing this, IUPAC rules, there's no space here. If you do put a space there, I'm not going to take off points. If it's on separate pages of the test, yeah, that's too much. Oh, someone have a question? Or don't forget to keep your mic off, unless you have a question. All right, let's move on. You know something? I just looked at the clock. And time flies when you're having fun. It's time for my stretching break and your break. So I'll see you in 5 minutes, 1:55. And with that, I'm going to go stretch because I've been sitting for too long. I'll see you in 5 minutes. I don't want to do it too loud. It's my storm whistle. I'll get my tags. All right, let's get back to where we left off. Hopefully you all regenerated, charged up your battery for another fun segment of organic chemistry with your host, me, Dr. White. Remember, there's 4 bonds to carbon. 4. Truthfully, that is your friend. Quick thing, everybody see the whiteboard with the carbons on there? Everybody give me a thumbs up if you can see the whiteboard here. Thank you. In real life, if you were in the classroom, you'd be waiting while I put in the hydrogens. Remember, it's your job. And I'll ask you once again, what's the IUPAC name for the following molecule? And the question you first have to figure out is, what's the longest chain? Once you do that, all right, let's find out if you were right. If we go here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we start here, we could go 1, 2, 3, 4, 5, 6. And we could also go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the longest chain was 10 carbons. So in case you haven't learned it yet, hint, hopefully you'll get on it. What's 10 carbons? Time's up, is decane. So the root name for this is decane. As soon as I say decane, all that's spoken for. And notice we have something left over. And that's the alkyl group. How many carbons in there? 2. Notice you have 2 carbons here attached to the long chain. And hopefully soon you'll learn this table. The alkyl groups, 2 carbons attached to long chain is called ethyl. 2 carbons, long chain, ethyl. So now we have ethyl decane. Am I done? No, you have to number it. I'll give you 5 seconds. I'll be generous. 18.7 seconds to figure out what carbon is the ethyl group on. All right, let's take a look. You always start numbering from the ends. Common mistake students make on test number 1 is they say, I'm going to start from the carbon of the ethyl group or the alkyl group. Is that wrong? So this would be 1, 2, 3. It's on carbon 4. If I start from the other side, this would be 1, 2, 3, 4, 5, 6, 7. And now you have to use your high-level math skills for this class, which is a smaller number, 4 or 7. Time's up. Hopefully you all picked 4. So we now have 4-ethyl decane. That's the IUPAC name for that. Ooh, something I should mention. I could spell. All right. One of the things, if you're ever wanting to find a structure, and I can't spell, actually, I picked up. Put in the name, the word structure, then wiki. That'll take you to Wikipedia. Here I have an octane. And one of the nice things about Wikipedia has been so heavily policed by organic chemists and chemists in general. And I can only say this for chemistry. I don't know about anything else, that anything you find in Wikipedia, for the most part, like 99.9%, is going to be correct. Now, if you look over here, notice they have this structure for octane, and they have the expanded view, and they have these molecular models, which for this one is totally useless. Now, this is called the line method. Every bend in a line is carbon, every end in a line is carbon. Dr. White knows how to do that, and I'll be teaching you how to do that with a ring. But for alkanes, this is extremely challenging for new students like you. So I stay away from that this semester for alkanes. For rings, I use it, it's easier. But if you look at here, they have useful information, such as the IUPAC name, density, odor, boiling point. Oh, isn't that unusual? Gasoline, odor of octane smells like gasoline. That's because a good part of gasoline is isomers of octane. Here's the boiling point and melting point and different important information. So what I wanted to show you was, if you go to Wikipedia for things on organic chemistry, you can trust it. All right, let's continue on with nomenclature. Let me remind you, nomenclature is like going into a very high class, very expensive restaurant and ordering a couple pieces of dry white toast. It'll keep you alive, but it's not the most exciting thing on the menu. Right now, we're in the dry white toast stuff, but it's important to know. Now, question would be, what's the IUPAC name for this molecule? The first thing you have to do is find the longest chain. And for this case, 1, 2, 3, 4, 5, 6. And you could also count 1, 2, 3, 4, 5, 6. This counting from here either way will give you less. So 6 is hexane. So as soon as I say hexane, this is counted for. Oh, look, CH3, methyl group. There are 2 of them. And when you have 2 of something, we use the prefix di. When you have 3, we use the prefix tri. 4 is tetra, and I've never encountered that in my career, so I don't think you will either. So what do we have here? 2 of the same group. CH3 is methyl. Now, how do we tell everybody there are 2 of them? In front of the methyl, use the prefix di for 2. If there were 3, and this is, I put capital, but technically if you type it out, even though I don't care, it should be all lowercase. It's dimethyl hexane. Now we have to figure out what numbers are the carbon. For every alkyl group, you need a number. Therefore, when I see di, I need 2 numbers. Now, if I start numbering from this way, it would be that. They're on carbons 2 and 3. If I start from this way, they're on 4 and 5. And now, once again, you have to use your high-level math skill, which is the smaller numbers. And hopefully you all pick 2 and 3. How do you show that? The first methyl group is on carbon 2. When you have 2 numbers for like dimethyl, use a comma. Second one is on 3, then a dash. If you forget the dashes, I never take points off. Commas, yeah, it's important, otherwise it's 23. So this is 2,3-dimethyl hexane. Longest chain, 6 carbons, hexane. CH3, methyl groups, there are 2 of them, dimethyl, and they're on carbons 2 and 3. Now, in IUPAC names, you never assume, never. Does everybody know why there's no hydrogen on this carbon? Because there are 4 bonds to it already. Remember, you should only have 4 bonds to carbon. Ooh, I stuck that in. Now the question would be, what's the IUPAC name for that? I'm going to do this, and then I will share and let you have some fun. Longest chain, 1, 2, 3, 4. For these examples, I'm making it easier for you. It's a cross. It doesn't have to be, if I started here or here, it'd still be 4. And that's butane. And again, know that chart. This weekend, you should be learning it. So I have 4 carbons. What's left over? CH3, CH3. Oh, it's a methyl group. And remember, di is 2 groups, tri is 3. And I have 2 groups, so therefore, this is dimethyl. That looks awful. Dimethyl. Now, what carbons are they on? Well, if I start from this way, it's 1, it's on carbon 2. If I go the other way, 1, 2, 3. And what's the lowest number? I hope you all admit 2. Now, listen carefully. There are 2 groups. Therefore, I should have 2 numbers. Even when they're both on the same, if you just put this, I don't know where the other methyl group is. What you have to do is put the second 2. So this is 2,2-dimethyl butane. Again, 2 of the same alkyl group, di, 3, tri. Remember, it's your responsibility to let me know if I make a mistake with hydrogens. And now it's time for you to have some fun. What's the IUPAC name for this? First of all, what's the longest chain? Everybody figure out what the longest chain is? Because now I'll switch over in case you haven't learned this chart, and I'll put out an email recommending everybody either print out or write this out. Hopefully you picked the longest chain was 8, octane. Let's go back to the structure. And I'll let you finish the names. You already know what a CH3 group is, I hope by now. And when you're done, give me a thumbs up. And mainly for those of you who don't have your video on or you don't have web cameras, if you're done, give me a thumbs up with the emotion or whatever they call it. All right, I think everybody's done. Let's go ahead and do this. All right, the longest chain, as I said, is 8. 1, 2, 3, 4, 5, 6, 7, 8. I start here, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. So the longest chain, I was right, 8, octane. And hopefully you've learned that chart over the weekend between now and Monday. You know that chart as well as you know your first name. And I'm assuming all of you know your first name. So as soon as I say octane, that's all spoken for. What's left over? Oh, it's your good friend, the methyl group. How many are there? There are 2 of them. Therefore, we have methyl. That looks nicer. Methyl. There are 2 of them. Remember, 2 groups are di. The prefix, that's the part that goes in front. 3 groups are tri. When we get into aromatic compounds, tri will come up. So this is dimethyl. Now, since you see the prefix di, I need 2 numbers. One way, it's on carbon 2 and 4 of the methyl. If I number the other way, always number from the end. 1, 2, 3, 4, 5, 6, 7. So one way would be 2 and 4. The other way would be 5 and 7. Use your high-level math skills, which is the lower numbers, and hopefully I'll pick 2 and 4. So this would be 2,4-dimethyl octane. All right, now, There are two types of skills you should have in nomenclature. Remember, nomenclature is a fancy word for naming compounds, and I'm talking about using the IUPAC, the official rules. One thing we've done is, here's the structure, what's the IUPAC name? And now the other one is, here's the name, give the draw the structure. And on test number 1, because we're going to spend a lot of time on that, that's going to be about 40 to 50% of the points, because it's the start, and later on it drops lower, but at the beginning we're spending more time there. So let's look at the following. If we look at this, you see the name propane. You learned that's 3 carbons. How do you do that? You also know there are 4 bonds to carbon, therefore this one needs 3 more. This one has 2 bonds, 4 minus 2, 2 hydrogens, and this one has 1 bond, and therefore 4 minus 1 is 3, and that would be propane. And I'm going to let you have some fun too. Why don't you draw the structure for butane? If you haven't learned table for the IUPAC names, that's 4 carbons in a straight chain. Those who are quicker, please be patient. I try and give everybody time to finish. All right, I think everybody's done. If you look up butane, you know that's 4 carbons, a straight chain. And now, how many bonds to carbon? 4 bonds to carbon. And I'll put in the hydrogens. And that's how you do it. Now, let's continue on. What happens if you have an alkyl group on there? And let me do this one again, is draw the structure. How do you decode this to know what to draw? Well, it's always the same in organic chemicals, the names. You start from the right and you move left. And the first thing I see is heptane. So that tells me the root chain, heptane is an alkane, is 7 carbons. Next, I have a methyl group, and I've learned that table. That's CH3. And here you see the number 2, and where is the methyl group on carbon 2? 1, 2. Now, one of you might have said, wait, what if I started from here? 1, 2. And the question is, can you do that? And the answer is, yes, you can. And if I go ahead and write another structure, here's 7 carbons, 1, 2, 3, 4, 5, 6, 7. The methyl group is on carbon 2, 1, 2. And that would be that. Remember, there are 4 bonds to carbon, so I know how many hydrogens. At this point, a student would ask me, which is the right one, A or B? And the answer is they're both correct. What? They're both correct. Now, here's something I have to teach you, and that is molecules, just like us, are not flat on a piece of paper. They're in 3 dimensions, like my hand moves. And if I were to say, oh, look, here's my hand. If I said, close your eyes now, and I did this, oh, look, something different. You say, no, you just rotate your hand around. And molecules don't exist flat, bonded or glued to a piece of paper. They move around in 3 dimensions in our life. And therefore, if I go back to this, you'll see this 1A, if I rotate it 180 degrees this way, I'll get B. And same thing here. If I take this and rotate it 180 degrees, I'll get that. Question is, which one is right on the test? And the answer is, they are both correct. You only have to do one. For the most part, most of you are going to start on this end. Later in the semester, because the way organic chemists learn this from other organic chemists, I'll mostly start on this end. But you can do either one, and that's because I have a piece of paper from the Board of Regents of Michigan State University saying I understand that. In other words, my PhD degree. And I'm going to let you have some fun. Why don't you draw the structure for 2-methyl nonane? Let me help you out real quick. 2-methyl nonane. Can you all see nonane on the table? Hint. Hint. Everybody got that? Now you see why you have to learn this table. And what? Why don't you draw 2-methyl nonane? Organic chemistry isn't that bad. I hope none of you are suffering from doing this stuff. See, it's fun. If I say that enough times, you might believe me. It is, though. Trust me, I'm an organic chemist. All right, anybody need more time? All right, looks like everybody's done. Let's go and do this. So how do you decode this to know what to draw? Well, you start from the right and go left. And the first thing we see is no name. That's the main chain, 9 carbons. I have 9 carbons, and therefore this is spoken for. Next thing, I have methyl, and you know methyl group is CH3 attached to it. It's on carbon 2. I can go 1, 2, or I could do 1, 2. Most of you are going to start on this side, and usually, except for what I did earlier, I'm only going to draw one way of doing it. And so carbon is here. And remember, there are 4 bonds to carbon. I take off points if you don't put in hydrogens, because that's part of what we're learning, you're learning. And this would be 2-methyl, no name, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how you do it. Now, let's look at one other case that you should be familiar with. Which I should have done in structures, but now I'm realizing I didn't, but I'm doing it now. Let's look at this. And if we look at this, how many carbons long chain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be decane. Next, we have a methyl group and an ethyl group. And if we started from here, it would be on carbons 3 and 4. If we go the other way, 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the methyl group, the lowest numbers are 3 and 4. The methyl group is on 3. The ethyl is on 4. Now, IUPAC rules are when you're putting the groups in front, the group with the highest alphabetical priority, that means closest to the front of the alphabet, goes first. So this would be 4 ethyl, 3 methyl. Now, this is the alphabetical rule in IUPAC. This is one of the few times I'm going to say this. I will not hold you to this. If you were to write 3 methyl, 4 ethyl, technically, by the IUPAC rules, it's wrong, but the way I grade it's right. Why? Because they're gray areas. And if you're not going to be becoming a chemist, I'm not going to push you to learn all the gray areas. What do I mean by that? If we look at the alkyl groups, when you're looking at alphabetical priority, the prefix N or isopropyl, N or tert is not considered. N-butyl, N-propyl, isopropyl is considered a P, N-butyl and tert-butyl are a B. Now, if you have both of these, then you consider it, and I'm not going to get that deep into the rules. So, my gift to you today, it's a little gift, but that is, I will not hold you to the IUPAC alphabetical rules. why don't you try and draw the structure for 2-methyl, 3-ethyl decane. Remember, decane is 2 carbon, is 8 carbons. No, it's 10. Over here, decane 10. And let me, in case you forgot, methyl 1 carbon, ethyl 2 carbons attached to longer chain. Again, ethyl 2 carbons, methyl 1 carbon. All right, I think everybody's done. Excuse the phone call. I'm going to let my answering machine 2 more rings while I'm doing that. Done. All right, sorry about that, but since I consult, and if I see a number I don't know, it might be a new customer calling me, and they'll get my answering machine. All right, question is how to draw the structure. Always start from the right and move left. Decane, 10 carbons. Next, I have an ethyl group, 2 carbons, and a methyl, which I forgot the L, methyl, 3 carbon, on carbon 2, 1 carbon. So if I start here, you could have started here, but most of you are going to start over here. So on carbon 2 is a methyl group, on carbon 3 is an ethyl group. You could point it this way or angle it, it doesn't matter. There's free rotation around the carbon-carbon single bond, just like you can rotate your hand, this rotates, and therefore, I'm done. Nope, we got to put in the hydrogens. Remember, it's your solemn responsibility to make sure I don't make a mistake. If I do, you let me know so I can correct it. And that's how you do it. 2-methyl, 3-ethyl decane. And that's how you do alkanes. Now, there are other alkyl substituents that I could talk about, but I'm going to wait until we get into aromatic compounds with the halogens. Now, I've already covered number 6. If 2 or more different types of substituents are present, they're listed alphabetically, except prefixes I forgot to mention, but this is true. Di and tri are not considered when alphabetizing. I'm not going to hold you to this rule. Punctuation is important. IUPAC names, hydrocarbons are written as one word. If you got a space in there, I'm not going to take off points. Numbers are separated by commas. That's important. And numbers and letters are separated by hyphens. If you forget a hyphen, that's okay. No space between the last name substituent and the parent or the main chain. I've done that. All right. I'm not going to talk about the halogens. We've done the alkyl groups. I've already done this. You should know 1 through 10. You should know. Now, here I have the halogens. Let's hold off on this until we get to the chapter on aromatic compounds. I think that's chapter 4. Let's move on to rings. In case you don't know, Dr. White and Mother Nature love rings. I really do. Now, when we talk about the cycloalkanes rings, it's similar to nomenclature for alkanes. Now, the ring portion serves as the base name, but the prefix cyclo is used to indicate the presence of a ring. Again, the ring portion serves as the base name, same chart as you looked at the alkanes, but we now use the prefix to tell it's a ring, cyclo. Let's take a look at those. By the way, let's find out if I'm having a good ring drawing day or a bad one. That's better. And if you look at this, what's its IUPAC name? Well, how do you do that? Well, you don't find how many carbons are in the longest chain. You find how many carbons are in the ring. And every bend in the line is a carbon. And if you look at this, 1, 2, 3, 4, 5, 6. 6 carbons alkane is hexane. But this is a ring, and therefore we call that cyclohexane. You use the prefix cyclo when you have a ring. And Dr. White really and Mother Nature love 6-membered rings, cyclohexane. Now, let's do another ring. I'll let you count how many bends in this ring, or also how many sides. Time's up. There are 5. Let's look at them. 1, 2, 3, 4, 5. And 5 carbons is pentane. But it's a ring, so we need the prefix cyclo, cyclopentane. Now, on test number 1, students tend to forget when they're naming a ring like this, the word cyclo. Don't. I'm telling you that so you won't get it wrong on a test. When you have a ring, you need the prefix cyclo. And if I look at the clock, I can look at it, hold on. We're just about ready to take a break. Let's do one more ring, then we'll take a break. Five-minute stretching. Now, you call this a square. Organic chemists call that a ring. How many carbons in that ring? Since we're near break time, I'll give you 15 seconds. Go. 14.2, 14 point, time's up, and the answer is 4. 1, 2, 3, 4. 4 is butane. It's a ring. It's cyclobutane. It's all one word, cyclobutane. With that, let's take a 5-minute break. Come back at 2:45. That's when the big hand is on the 9, and I'll see you in a little while. All right, everybody back and ready to go? All right. I see a thumbs up. So, a couple people are out there. I'm not alone. It's still unusual being in my office doing teaching. One nice thing, it's cut down by about 10 hours a week, my commuting time, which is quite nice. All right, something I should mention, normally on Wednesdays, I would have lectured for 50 minutes, take a 5-minute break, then we get into lab. Lab is, I discussed the lab, and in real life, if we were at ECC, take a less than 20 minutes, and which we'll do, then I'd send you into the lab. Well, I can't send you into the lab now, but we're going to get out early most Wednesdays. So in real life, if you were at the lab, most of my labs, you get out way before 3:50. So you're not doing anything different, other than you can't manipulate the chemicals. I wanted to mention that, but why am I going longer now? Because I think it's a week from this Monday will be Labor Day. Wow, this year has gone like that. And we're not going to have class. And I'm going to lose my major lecture day. And that's why I'm sneaking in time today, extra. And also next Wednesday, I'll put in a little time because we don't really need the safety video because you're not handling chemicals or equipment. All right, let's get back to nomenclature. And this is important. Thing you need for foundation of organic chemistry. Now, one more ring I should mention. You call that a triangle. I call that a ring. 3 carbons pentane. What am I saying? Propane. And it's a ring, therefore, this is cyclopropane. Let me write it better. Cyclopropane. Now, in my career, which means same thing for you, I've only dealt with mainly in terms of cycloalkanes, 6-member rings, cyclohexane, 5-member rings, cyclopentane, 4-member rings, cyclobutane, and 3 cyclopropane. Now you can have larger ones, but I've rarely encountered them. But there's one I'd like to show you. You don't have to write this down. This will never be on a test. And this has, you can't see this bend really well, 8 sides. And this is octane. It's cyclooctane. Let me try a better cyclooctane. That's a little better. And when I look at cyclooctane, actually when I'm driving, I think of cyclooctane a number of times. When you see this. And if you look next time at a stop sign, it has 8 sides. Whenever I see a stop sign, I think of cyclooctane. So if I were to ask, give the IUPAC name for the following, why don't you try that? How many carbons in the ring? I'll give you 20 seconds, then I'll show you a table. That'll help you out. Five carbons in the ring. Pentane. It's a ring, so I'm going to give it away. Remember, you need for rings cyclo in front of the word pentane. I'm telling you this because I've seen students lose a lot of points on test one. They just put down pentane. All right, now let's talk about alkyl groups on rings. Let's see, if you have one substituent present, then no number is needed. And I'll explain why when I show you the following. If we look at this, we have 6 carbons in the ring. That's cyclohexane. And we have a methyl group. So it's methyl cyclohexane. That looks better. Now, students are wanting to put a 1 there. They say that's 1. And the answer is no, no number needed here because there's only one alkyl group substituent on the ring. Because let me draw this molecule. And if we look at this, you'd say, what's the name of that? If this is 1, is this 2? No, this is still carbon 1. Why? All I've done is rotated 60 degrees that way, and this is still methyl cyclohexane. So when you have one alkyl group on a ring, you don't need a number. So it's time for Dr. White to let you try one. And take a look at the substituent, how many carbons, which carbon of these carbons is attached to the ring. And now I'll help you out because you haven't learned it yet. 3 carbons to the N carbon. What is that called? N-propyl. And why don't you try writing the name? All right, I think everybody's done. What do we have here? 1, 2, 3, 4, 5, 6 carbons in a ring. Hexane. It's a ring. Cyclohexane. Next, I have an alkyl group, 3 carbons. Propyl is to the N carbon of 3, N-propyl. And therefore, this would be N-propyl cyclohexane. Say that 3 times quickly. No, you don't have to. Oh, let's do one more. These are fun. Not if I draw a ring that way. Uh-oh, I'm having a bad ring drawing day. First of all, how many carbons in the ring? Hopefully you got that number. Everybody count that. Let me go and help you out. It was 5. 5 is pentane. If we're in the class, both these screens would be up on, these pages would be up on the screen and the structure would be on the board. Now, Notice I had the 4 carbons, 3 carbons to center carbon, and what is that called? Tert-butyl or T-butyl? Therefore, 5 carbons, pentane, it's a ring, cyclopentane. I have here a T-butyl group, 1, 2, 3 carbons to a center carbon to the ring. That's tert or T-butyl, and next week I'll be lazy organic chemist. And no number because it's the only alkyl group, so that's tert-butyl cyclopentane. And Dr. White is smiling because Dr. White loves rings. Don't forget, there's no such thing as a dumb question in my class. So if you have any questions what I'm doing, always feel free to ask. Now, what happens when there are 2 substituents on a ring? First of all, how many carbons on the ring? Or in the ring? 6. So that's hexane, it's a ring, cyclohexane. Now, you number the substituents so they get the lowest number. One of these will always be 1, the other will be the other number. Now, IUPAC has a rule which I will not hold you to, and that is the alkyl group with the highest alphabetical priority gets the lowest number. Therefore, this should be 1. Now, you can go either clockwise or counterclockwise. If I go counterclockwise, the methyl group is on 3. If I go clockwise, the methyl group is on 5. And when you do alkyl groups, you make this the lowest number, so the answer would be 3. Therefore, this would be 1 ethyl, 3 methyl, cyclohexane. This is the correct IUPAC rule name right here. But on a test, keep a secret. I will allow 3 other answers because I'm not going to hold you to this numbering rule, except give the lowest numbers. Therefore, you could have also had 3 ethyl, 1 methyl, cyclohexane. Now, you could have put the methyl first, made it 3 methyl, 1 ethyl, or you could have here put the methyl first, 1 methyl, 3 ethyl. All 3 of those I will consider correct because I'm not going to hold you to all the IUPAC rules that I know because none of you are going to become chemists. If you did, I would, but you're not. Be quiet. Shh, don't let the IUPAC police know about that. There are no IUPAC police. So it gets a little complex, but you'll see once you've done this a couple of times, it's not that hard. Let me go through this again. Get the ring. 6 hexane, it's a ring, cyclo. I have an ethyl and a methyl. The highest priority alphabet will be 1, but if you don't want to do that, that's okay. One of these will be 1, the other would be 3. Because if I name this 1, this would be 2, this would be 3. If I went the other way, this would be 5. And that's how you do it. Let me let you try one. And why don't you try this? First of all, how many carbons in the ring? And the answer is 5. So let's go to this chart. 5 is, oh, pentane. Now you know why you have to learn this chart. And then you know this is a methyl, this is an ethyl, and I'll let you try and finish it up. Remember, when you're done, give me a thumbs up real quick. Either if you got your video on, do it, or with the thumbs up button. All right, looks like everybody's done. Let's do this. All right, we have our ring, 5 carbons. 1, 2, 3, 4, 5. Pentane. Next, we have an ethyl group and a methyl group. This is going to be 1. And what is this? If you go counterclockwise, this would be 2. If I went the other way, this would be 2, 3, 4, 5. And you give the alkyl group's lowest number, and 2 is lower than 1. So therefore, this would be now, before you go erasing the answer on your sheet, if you put this first, that's okay. And this second. Don't tell anybody I'm letting you do this, but it's okay. And, ooh, quick thing. Did I tell you I'm this close to the person who grades the test? Me. So if I tell you it's okay, guess what? It's okay. Now, the other thing is you could have had the number switch. You could have called this 2-ethyl, 1-methyl. And you could also have the numbers and the order switch. And I would count those all correct. All right, let's do one more. Uh-oh, I'm having a bad ring drawing day. Sorry. As soon as I'm through doing this, I'll check who had a question. Did I forget the cyclo? I did. Thank you. Well, there goes my perfect score today. Bad, Dr. White. Thank you. So it should be 1-ethyl, 2-methyl, cyclopentane. See, I don't know if I told you this. I think I forgot to tell you this. I better tell you this real quick. The last I checked, I can't walk on water unless it's frozen. Even then I stay off it. So if I make a mistake, which is rare, and I hope I don't do that ever again, correct me. Thank you who corrected me. Why don't you try this one? What's the IUPAC name for that molecule? And when you're done, don't forget, give me a thumbs up. Six carbons, hexane. I think everybody's done. Let's take a look at this. What do we have? Six carbons, and that's hexane. It's a ring, so I'll not forget, like I did above. Oh, I will never live that down. No, I will. It's cyclohexane. Oh, look, it's your soon-to-be very good friend, the methyl group. But there are two of them. Number two, we use the prefix di. And if there are three, which we'll wait till later, is tri. And therefore, this is methyl. And now we have, oh, look, two of them di, and they're on the same carbon. And therefore, to give this the lowest number, this is carbon 1, this is 1,1-dimethyl cyclohexane. And that's how you do that. This is sort of a tricky one. Don't forget, you're all rookies in nomenclature. So right now you might think, oh, this is pretty hard. If you're new, it is. But in a couple of weeks, you'll look back and say, why did I think that was hard? Well, you didn't know it, and you hadn't practiced it. All right, there are two skills in nomenclature. One is, here's the structure, give the IUPAC name. The other is, draw the structure. And sometimes I'll put condensed structure for this. In rings, I always use line. If you want to show the carbons, you can, but you're wasting a lot of time. And if it was on a test, something like this would probably be about 3 points each. So how would you draw cyclobutane? Organic chemistry, you always start from the right and move left. Butane, 4 carbons, cyclo, a ring. Therefore, I have a ring with 4 carbons, and there you go. I'm going to let you have some fun. And why don't you draw the structure for cyclohexane? All right, I think everybody's done. How do you decode this name to know what to draw? Well, you start from the right. Hexane, 6 carbons. Cyclo, a ring. So I have a ring with 6 carbons. And by the way, if your ring doesn't look pretty and mine don't look pretty today, don't worry about it. If I can make it out, that's okay. And why don't you try this one? What? Wait, I do this in the classroom too. I put the answer down of what a question I'm going to put for nomenclature. If you haven't learned, propane is 3. Why don't you draw the structure for methyl cyclopropane? You're doing organic chemistry and it's not that bad. I hope. Remember, give me a thumbs up when you're done. Try and give everybody time. Or you can turn on your video and smile. All right, I think everybody's done. Let's look, how do you decode this? Start from the right. All organic chemical names are decoded that way. Propane, 3 carbons. Cyclo, a ring. Methyl group, CH3. Therefore, like I said, I am having I have a ring. It doesn't matter which carbon you put the methyl group on. Most of you will probably put it here. You could have put it there or there. All you're doing is rotating the ring around. And that's how you do, oh, let's do one. Nah, we've done enough. And that's how you do nomenclature of rings and alkanes. And on test number 1, there'll be 2 types of nomenclature question. And actually the ones are, like you saw, here's the structure, give the IUPAC name. Here's the name, draw the structure. Now, one of the things I forgot to do at the beginning of class, so I'm going to take a timeout for truly a public service announcement. Coming up in November is probably one of the most important elections, probably the most important election to me in my lifetime, hopefully to you. Brave men and women have died so we can vote. Please make sure you're registered. It's easy in Illinois. And please make sure you vote. Why am I telling you this? Because earlier today, I requested my vote by mail ballot or mail-in ballot from the Cook County, because I live in Cook County, what do they call it? Secretary of State, whoever. And I'll be doing that because at my age, I don't want to go to voting, especially with what's going on out there with the virus, because it'd probably be lethal to me if I ever caught it. And it still could be very dangerous to you. So make sure you're registered to vote. I think you can do that online, and make sure you vote. And if you want, request the ballot online. To the best of my ability, I think I've only missed one election all the years I've been voting, and that was a local primary, not a national or state. And that's because a couple of days before the primary, that's when I was in business industry, chemical industry. I had to make an important emergency business trip for the company I was in, and I was out of town, and it was too late to get a absentee ballot. But I've never in my life missed a statewide election or a national election. End of public service. All right, let's just talk a few things. I don't know if I mentioned this on Monday. Every once in a while, I'll do this, click, or I'll go like this because we're on a monitor, I'm on a webcam, click. The switch, will this be on a test, is then click the off position, just like a light switch. But it's still something you should be aware of. And sometimes in certain entrance exams, they put questions like these. When we talk about alkanes, important thing to remember is the boiling point. And we'll find out this is true for a lot of things, but the boiling point, the more carbons, which means the chain length increases, the boiling point increases. So the boiling point will rise or increase as the chain length, number of carbons increases. Now, when you have branching, the branch chain is always less as the boiling point falls than the unbranched. That's because it's more spherical in shape. I'll never ask this on a test, but I've heard on certain exams, entrance exams, where they have an organic chemistry part, they ask the stupid question, in my mind is stupid, but it's still good to know, but I would never ask it on my test or final. The more carbons, the higher the boiling point. You have two isomers. The ones that is straight chain always has a higher boiling point than the branch chain. Switch is still off. You can have what's called conformation or conformers. This still is with 3D. I don't have my models, so I'm just going to skip it. All right, let's talk about reactions. One of the most important things in organic chemistry, because of me, I'm a synthetic organic chemist. What does that mean? Synthetic or synthesis is a fancy word meaning to make. And my training has been how to make molecules. And in industry, after I got my PhD, how to make molecules that do certain things. One of the type of molecules that's still being used that I invented years ago is a fabric softener. Another one is an antimicrobial compound that kills certain bacteria. And I think it's also, it could be even good on certain viruses. I don't know about that. And that means to make. So important thing is reactions in organic chemistry. And that's going to be an important part of this class. Now, the good thing is in organic chemistry, we have what's called general reactions. Whenever you have that kind of setup, or we'll learn later, functional group in a molecule, it always reacts the same way. Just like I know to use that door to go to one room to another, I'm sitting on a chair, and I know that's not used to play hockey with or other things. That was a stupid thing, well, not stupid, bizarre thing to say, but I can do that once in a while. So let's look at chemistry of alkanes. Now, it turns out the chemistry of alkanes are about as exciting to organic chemists as going into a restaurant and saying, have a piece of dry white toast, but at the same time, it's our daily life, what I'll show you is quite critical. Now, when we talk about alkanes, if you take an alkane, which generally has this formula, react with oxygen, you need a spark, you'll get carbon dioxide, water, plus heat. This is called combustion. You can also use, how did my pen change color? You can also have cycloalkane. So anytime you have an alkane or a cycloalkane reacted with oxygen, you'll get carbon dioxide, CO2, and water. You'll also get heat. Now, to organic chemists, when we're looking at the products, ooh, that's something I need to talk about. Okay, so it's been a while since you had chemistry. Let's assume I have a reaction. A plus B goes to C. Everybody see that on the screen? Thumbs up, people. Thank you. And you should know these are called the reactants. If I could spell it right. But if you come from industry, which I do, more likely I'll call them the starting materials. I'll never ask you on a test what's a reactant or starting material. But I'll use this terminology. So at the base of the arrow, what's here, A and B are reactants, or more likely I'll call them the starting materials. What's at the head of the arrow is the product or products, if there's more than one. And in industry and academics, we both use the same thing. So that's the term. Now, organic chemists, because we're lazy, A plus B, A and B react to make C. We can also write it this way. For this reaction, I won't, but other times I'll do that. This means the same thing. You can put it on top or underneath. A reacts with B to make C. A and B are the starting materials. C is the product. And that's something I'll be using throughout the semester, and organic chemists just use that. I don't know how that evolved, but that's the convention. Now, I'll say on the whiteboard, the general reaction is alkanes or an alkane or cycloalkane plus oxygen gives carbon dioxide plus water. Heat's not a chemical, so I'm not going to put that down. Because on a test, I'll ask, give the product or products for the following reaction. Well, I'm not going to do this on a test. What will I do is this. And the question would be, let me write the question. I'd say give the products. When I say give the product or products, that's a bracket with an S in there. That means draw it. And if I write on the test this, you've got to write over here the product or products. What do you do? Well, first of all, you look at the reactants. Ooh, what's different about this? It's an alkane. What's different? Oh, it's oxygen. And you have learned this general reaction. What I mean by learn, you memorized it. Whenever you take an alkane plus or a cycloalkane oxygen, you get CO2 and water. You've learned that. And therefore, if I look down here, you've memorized this. Alkane or cycloalkane oxygen gives CO2 plus water. Now, good news, organic chemists are lazy. We are. And we don't balance equations unless we have to. When I ask for the products, I'm not asking you to balance it. So in this class, you'll never have to balance the equation. Therefore, the answer here is CO2 plus water. Now, why don't we balance it? Because I don't need the coefficients, what goes in front of here, unless I'm trying to determine charge weights. How much of this and this do you need to react to make that? You'll never do that in my class. So the answer here would be CO2 and water. Let's do another one. And why don't you try this one? What would be the product or products for the following reaction? And remember, give me a thumbs up when you're done. I think everybody's done. Now, what's the mindset? You look here and say, oh, what's this? Oh, it's an alkane, butane. Now, it could have been a cycloalkane. It's not. And I'm reacting with oxygen. And you have learned, what do you get? Carbon dioxide and water. Therefore, what's the products here? Carbon dioxide plus water. Now, common question students will ask is, do I have to write on a test the general reaction underneath? And the answer is no. In this class, I always will to help you remember it. Now, I can tell you this, some of the best students I've ever had in Chem 170 always write this underneath. Some of the best students I've ever had in Chem 170 never write this underneath. But somehow this has to be in your brain. The best way to memorize a general reaction is write it down and say it 5 times. Write down alkane or cycloalkane plus CO2 gives CO2 and water. Write it down and say it. If you do that 5 times, I don't know why, I'm a chemist, not a psychologist, it really burns it into your brain. Now, let me teach you, remember, this is something confidential. Let me teach you the chemistry instructor's favorite trick on a test. And that is put a real scary molecule, big scary molecule. And I'll let you try this one. What would be the product or products for the following reaction? And remember, give me a thumbs up when you're done. I think everybody's done, so let's take a look at this. Now, if you haven't studied and you don't know, oh, this is only carbon, hydrogen, carbon, single bond, you look at that and you go, eek. I don't know if you saw that. Hold on. Time for Dr. White to be silly. You look at that and you go, eek. Hopefully you'll never do that on a test of mine, because you've learned a general reaction. You say, oh, carbon and hydrogens, carbon, single bonds, this is an alkane. And it could have been a cycloalkane. I haven't done any rings today, but maybe Monday next week I will. And I get CO2 plus water. And therefore the answer here, CO2 plus water. And that's how you do it. Now, this is a general reaction. This right here or this right here, same general reaction. You need to know that for test number 1. This semester, relax. One of the students in Chem 170 a couple years ago, and I don't know if she was right exactly, said during the semester, you'll learn about 52 general reactions. Relax, take a deep breath, let it out, relax. And students usually, I expect in my class, I usually get it, usually about 70 or higher % of the class earn A's because they learn the nomenclature rules and practice them with the practice problems, and they learn the general equations, reactions, and practice them. And they'll learn it. By the way, I think realistically, I think I know about 400 general reactions, but I'm a synthetic organic chemist. And that's part of my life and livelihood, and I should know things like that. Wrong one. All right. One more thing I'll do on the whiteboard, which I like to do, is alkanes. And I should have a slide for this, but I don't, so I'll apologize. Everybody see the whiteboard? Okay. And this is something you should know, so I take notes or go back and look at the video. The simplest alkane, methane, CH4, you know as natural gas. And that's what you use to cook for. This one you already know, and you don't have to know the structures, but, well, you should for nomenclature. Propane, and that's for your barbecue. And if we go larger ones, octane, you find in gasoline. Now, if you get to very larger alkanes, we can have something called baby oil. Baby oil is this very long chain, I think 20 or more long chain alkanes with some perfume in it. Years ago, I had a neonatal nurse who warned everybody, which I knew, but I didn't realize I should have warned them. Baby oil is quite flammable. And nurses always warn people who with newborns don't smoke or have candles around when you use baby oil. It's flammable. Now, if you have even longer chains, we have something called petroleum jelly, but you know that as Vaseline. And Vaseline is much longer alkane chains like 25, 30, or 40. And that's also flammable, not as flammable. If you have really much longer chains, we call that paraffin wax. I don't know if I'm spelling paraffin wrong, I always do, wax. And 50% of any candle is paraffin wax. Now, these are things you should know, some of these, because on a test I could ask, give an example of an alkane you use in your daily life. And you could use any of these. And that could be methane, natural gas, propane, barbecue, octane, gasoline, baby oil, Vaseline, and paraffin wax. And the next time you look at a candle, think about that. You're looking at alkanes. The next time you look at baby oil or Vaseline, you're looking at alkanes. Everybody have that written down if they wanted to. If not, you can, by tomorrow morning, I'll have this video posted. Now, I promised I'd go through a method today, but I think I'm going to hold off till Monday because a number of people are not here, and I'll put it out in an email to let people know they should. And that is how to reduce test anxiety. I'll hold that off till Monday because I'm going to cut it out in a video when I would do that. So, because someday I'll try and sell it again. I tried once and I just didn't have the money to advertise it properly. But you'll get it free. No, actually not free. You have to pay to take this course. With that, looking at the clock, I'm done for today. I'm done for the week. And good news, you survived the week, first week of organic chemistry. Hopefully it wasn't that bad. Remember tonight, I'll have my office hours on Zoom from 6 to 7:30 if you need help. With that, I'll say, have a great rest of the week. Stay healthy, be good, gehen gesund. Bye.